Welcome to Cambridge Chemistry channel by Sarbat Ahmed. Today I will discuss October-November ATP paper 2022. This is 4-1 paper, and you know that in 2023 ATP paper 4 pattern of paper 4 is going to change. So in this paper I will discuss some selective questions which can be assessed in 2023 paper according to the new pattern. So first question is, two gases A and B have properties shown. Gas A less denser than air, solubility in water insoluble, colorless. B less denser than air, soluble, and brown colored gas. Some sets of apparatus P, Q, and R used to collect gases are shown. This setup is used the gases which are heavier than air, which are more denser than air. So this P, Q, and R, and this setup is used to collect lighter gases and soluble in water, and this setup is used to collect gas which is insoluble in water and lighter than air. So name the apparatus D. The question is name apparatus D. Where is D? Name apparatus D. So this is the boiling tube. Boiling this is boiling sorry this is D apparatus is boiling tube. Boiling tube. Q is used to collect gas B. Q is used to collect Q is used to collect gas B. State why R is not used to collect gas B, as it is soluble, or you can write down gas B is soluble in water. Gas B is soluble in water. State why P is not used to collect gas B. Why P is not used to collect. So gas B is P is used for the gases which are more denser than air. So gas P is less denser than air. State why R is more suitable than Q to collect gas A. Why R is more suitable to collect gas A. Gas D. State why R is more suitable. R is more suitable than Q. So it is gas A is insoluble in water. Next question number 2 is student electrolyzes two aqueous solutions using the apparatus shown. Carbon anode and cathode. Solution is complete the table. aqueous copper 2 sulfate oxygen at positive anode. Oxygen observations are bubbles of gas, or you can write down effervescence, bubbles of gas. And anode concentrated aqueous sodium chloride, bubbles of green gas, bubbles of green gas. And at cathode, name of product. So copper is less reactive in this solution because this solution contains two copper 2 ion, so 4 2 negative, H positive and OH negative. So due to the selective charge, copper 2 ions is below in the reactivity cities than hydrogen ion. So the product at cathode will be copper. And observation, pink solid deposited on cathode. Hydrogen observation is bubbles of gas. Describe the test used to identify chlorine gas. Test with the damp. Take the take damp litmus paper near the gas jar. Chlorine bleaches the damp litmus paper. Chlorine gas is toxic. Describe a safety precaution that students should take because of this hazard. Chlorine is a toxic gas. Describe a safety precaution that the student should take because of this hazard. This experiment should be carried out in fume cupboard. Question number 3. Calcium carbonate reacts with dilute hydrochloric acid. A student, this is a chemical equation, investigates the rate of this reaction using 3 different concentrations of hydrochloric acid. So loosely fitting, this is conical flask, loosely fitting the bowl plug, dilute hydrochloric acid, and this is sample bottle, calcium carbonate. The student adds all of the calcium carbonate in the sample bottle to the hydrochloric acid, dilute hydrochloric acid in E, replaces the sample bottle in the balance, records the mass every 30 seconds. Name apparatus E. Apparatus E is the conical flask. Carbon dioxide gas is a product of the reaction. Describe test used to identify carbon dioxide gas. Gas pass through lime water. Carbon dioxide gas turns lime water milky. Explain why the mass decreases as the time increases. Gas gas escapes. Student uses the measurement of mass as time increases to determine the rate of this reaction. State are different measurements that the student could make as time increases to determine the rate of this reaction. Volume. State a different measurement that the student could make as time increases to determine the rate volume of gas. To measure the volume of gas. In each of three experiments, the student chooses a different concentration of hydrochloric acid. All other variables are kept constant. Different concentrations, all other are constant. Three experiments are labeled X, Y, Z. The concentration of hydrochloric acid is going to decrease from X, Y, Z. The hydrochloric acid is in excess in each of the, it means hydrochloric acid is excess and is in excess of three experiments. Catalyst is not used. Identify two variables that should be kept constant in this investigation. So one is the temperature, particle size, and mass of carbonate. So the student plots a graph of the results. Describe how the graph is used to decide which experiment has the greatest rate. Steepest the graph, steepest the curve or gradient, fastest the rate. So experiment, write letter in each box on the graph, identify experiment X, Y and Z. Describe how the graph shows that the reaction stops. So X, Y, Z, look at here. In X, more concentration and concentration is decreased from X to Y and Y to Z. So this is X, this is the fastest because more concentration and particles become crowded and have more successful collision. Second is Y and third is Z. Okay, describe how the graph shows that the reaction stops. So graph on curves become parallel to the x-axis or graph become horizontal. You can say horizontal line, look at this, all at the same point. Horizontal line shows that reaction is going to stop, or gradient become constant. Explain why the reaction stop. The calcium, because hydrochloric acid is in excess amount, so calcium carbonate is in limiting calcium carbonate is limiting reactant, so all calcium carbonate is used up. This is the plan and design, and this is the most important question from the new pattern of ATP paper. A student is provided with two bottles labeled A and B and a supply of dilute hydrochloric acid. One of the bottle contains 1 gram of solid potassium carbonate, the other bottle 1 gram potassium hydrogen carbonate. The reaction between potassium carbonate and dilute hydrochloric acid is exothermic. It is reaction between potassium hydrogen carbonate and dilute HCl is endothermic. Plan experiment using the reaction of each solid with dilute hydrochloric acid to decide which solid is in each bottle and which reaction has the greatest heat change per gram of the solid. Your plan may use any of the apparatus normally found in the chemistry laboratory but no other chemicals. So, which solid is in each bottle? The reaction between potassium carbonate, one of the bottle contain, and the other is, we don't know about the bottle, that which were bottles labeled A and B, and is provided with two labeled bottles. So add 1 gram of potassium carbonate and potassium hydrogen carbonate labeled A and B in beaker containing thermometer and thermometer and excess dilute hydrochloric acid equal volume of, here we use at equal volume of HCl in both beakers. So the beaker in which temperature rises is potassium carbonate, while the beaker in which temperature fall is potassium hydrogen carbonate. Now check the final temperature in check the final temperature on the thermometer of both beakers. And calculate the largest temperature change and the beaker which shows the largest temperature change is equal to greatest heat change. So we know that the potassium carbonate reaction of potassium carbonate with HCl is the exothermic and this is endothermic. So in which temperature rises, that it means that that bottle contain potassium carbonate, and which temperature fall, that is potassium hydrogen carbonate. Question number 5. Solution K is an aqueous solution of sodium hydroxide. A student determines the concentration of solution K using a method that involves titration. The student measures 25 centimeter cube of solution K using a pipette. The solution makes up the solution to 250 centimeter cube with distilled water. This is solution L. Explain why a pipette is used instead of measuring cylinder to measure 25 centimeter cube of solution K. Pipette is more accurate. Name the container in which solution L is made. Volumetric flask. Volumetric flask. Pipette is used to transfer 20 centimeter cube of solution L into a flask. The pipette is washed out before measuring solution L. Identify the liquid that is used to wash out the pipette. The pipette is used to transfer solution L into a flask, 20 centimeter cube. The pipette is washed out before measuring solution L. Identify the liquid that is used to wash out the pipette, that is with solution L. The student adds 2 drops of methyl orange to solution L in the flask and then places the flask on a white tile. The student fills a burette with 0.100 mole per dm cube sulfuric acid. The sulfuric acid is added to the flask until there is a color change. Explain why the conical flask is placed on a white tiles. To observe the color change of the indicators clearly. State the color change of the methyl orange indicator at the end point. The color changes from yellow to red as sodium hydroxide is using pipette makes up to solution L. A pipette is used to solution L. So solution K, basically solution L is made up of from the solution K, which is sodium hydroxide. So sodium hydroxide is taken in flask and sulfuric acid is added to flask until there is color change, and sulfuric acid is taken in the burette. So color change will be from flask to burette. The liquid which is added to the flask until there is color change from the burette. So that is the from flask to burette liquid. So the color change will be yellow to red, because in methyl orange the color of methyl orange in sodium hydroxide is yellow, and in sulfuric acid it is red. Now fill the tables. So first fill the final burette reading. Final burette reading is 23.2 first iteration, and initial is 0, and second iteration is 46.5, and initial reading is 24.2, and in third iteration 32.7, and initial reading is 10.2. So to subtract initial from final reading, we get the volume of titrant, that is sulfuric acid, is 23.2. This is 22.3, and this is 22.5. So select the best titration results which are two values which are closer to each other. So this is 22.5 and 22.3. So by use the titration result to calculate the average volume. 22.3 plus 22.5 divided by 2, which is equal to 22.4. Calculate the number of moles of sulfuric acid and the average volume of 0.1. So number of moles sulfuric acid is equal to concentration. This is the concentration and this is the volume. So 0.100 into 22.4 divided by 1000, which is equal to 0.00224. The equation for the reaction of sodium hydroxide with sulfuric acid is shown. Use this equation to calculate the number of moles of sodium hydroxide in 20 centimeter solution L. By using this equation, so we have 2:1, and moles of sulfuric acid over here is 0.00224 ratio x. So the answer is 0.00448. Calculate the number of moles of sodium hydroxide in 250 centimeter cube of solution L. So calculate the number of moles of sodium hydroxide in 250 centimeter cube of solution L. 0.0025 250 centimeter cube, 20 centimeter cube solution contain mole ratio volume. This is contain 0.00448. 250 centimeter cube containing X. Cross multiply and we get 0.056. Reduce the number of moles in 25 centimeter cube of the solution K. So the same number of moles over here, 0.056. Calculate the concentration of solution K in mole per dm cube. Concentration is equal to mole over volume into 1000. So this is mole is 0.056 divided by volume is 25 into 1000. So the answer is 2.24 mole per dm cube. A different student does the same experiment using 20 drops of methyl orange instead of 2 drops of methyl orange. Methyl orange is acidic state. If the average titration volume of sulfuric acid is smaller, larger or unchanged when 20 drops of methyl orange are used. It is smaller instead of 2 smaller. As methyl orange neutralizes some of sodium hydroxide so therefore less amount of sulfuric acid is required to neutralize the rest of NaOH. So this is all about of this question. Next question is student, this is the identification of cations and anions question. This is also a very important part of the 2023 paper according to the new pattern of the ATP paper. So aqueous sodium hydroxide, blue precipitate, and aluminum sulfate with few drops white precipitate. Excess blue precipitate remains. Precipitate remains insoluble. White precipitate dissolves. Aqueous ammonia aqueous ammonia, pale blue PPTs with copper 2 sulfate. Deep blue solution. Aqueous ammonia white precipitate with aluminum ions. Precipitates insoluble. Aqueous silver nitrate solution, no change because sulfate ions are along with copper 2 ions, no change. And silver nitric acid, no change. Aqueous barium nitrate white precipitate, so this is also aluminum sulfate, so again white precipitate with barium nitrate. This is the test of sulfate ion, this is test of chloride ion. White precipitates. So identify X. X is because over here white precipitate, so this is the positive test of chloride ion over here. So this is red brown precipitate, or red brown precipitate is of iron 3. So the X is FeCl2 or iron 3 iron 3 chloride. This is positive test of chloride ion and no change. And this is test of red brown precipitate is iron 3 positive, and this chloride, so the ions are Fe 3 positive and chloride ion.